Okay class, welcome back. Today we are going to quickly work through hydrates and showing you how to work hydrate problems. My objective for you today is that you would be able to determine the formula of a hydrate. In saying that, let's dive into this lesson. A hydrate is a compound that has a specific number of water molecules bound to its atom. When writing the formula of a hydrate, the number of water molecules associated with each formula unit of a compound is written following a dot and the molecular formula. So, sodium carbonate decahydrate would be written Na2CO3 dot 10H2O. As you can conclude, deca means 10 and is paired with the formula H2O giving us our hydrate. We can put any numerical prefix to determine how many water molecules are involved in a hydrate. So 1 water molecule would be monohydrate, while 5 water molecules would be pentahydrate. When a hydrate is heated, water molecules are driven off, leaving an anhydrous compound, or one without water. You can calculate the empirical formula by finding the number of moles of water associated with 1 mole of an unknown hydrate. Let's say we have 5 grams of unknown hydrate of barium chloride. To find a specific type of hydrate, we are going to have to find how much water is driven off. Let's say after heating this hydrate and drying it out, the anhydrous barium chloride has a mass of 4.26 grams. In order to determine the number of water molecules driven off, we are going to have to take the mass of our hydrate and subtract the mass of our anhydrous from it. So 5.0 grams minus 4.26. This gives me 0.74 grams of water that is driven off through the dehydration process. Now that we know the mass of each of these substances, we can then multiply them by 1 mole over their molar masses to get the number of moles of each substance. So, for our water molecule, we have 0.74 grams of water times 1 mole of water over 18.02 grams of water. This gives us 0.41 moles of water. Next, we do the same thing for our 4.26 grams of barium chloride with its molar mass. We get 0.0205 moles of barium chloride. Now we take out our moles of water and divide it by the moles of barium chloride, and we get 2 moles of water per 1 mole of barium chloride. This means we have barium chloride dihydrate. Let's work another example problem. The mass of 2.5 grams of blue hydrated copper sulfate is placed in the crucible and heated. After heating it, 1.59 grams of white anhydrous copper sulfate remains. What is the formula for this hydrate? Well, our first step in these types of problems is to figure out how much water is driven off. So we take our hydrate weight and subtract our anhydrous weight from it. So 2.5 minus 1.59. This gives me 0.91 grams of water driven off. Next, we convert these into moles by multiplying the weights of the compounds by the molar masses. So 1.59 grams of copper sulfate multiplied by 1 mole of copper sulfate over 159.6 grams of copper sulfate. This gives me 0.00996 moles of copper sulfate. For our water, we take 0.91 grams of water and multiply by 1 mole of water over 18.02 grams of water. And this gives me 0.05 moles of water. Now we take our moles of water and divide it by our moles of copper 2 sulfate. So 0.05 divided by 0.00996. And we get 5.02, which is close enough to 5 to consider it 5. This means our hydrate is copper sulfate pentahydrate, or there's 5 water molecules. Okay, that's all I got for you today. I hope you learned something from this, and keep up the good work in the class. See you next time.